this video I'm going to demonstrate how to calculate area between curves. I have the two functions already on the screen, and the first thing I'm going to want to do is draw some kind of picture to represent what we have going here. And in order to do that, I'm going to need to find where these two functions intersect. So I'm going to set them equal to each other and solve for x. Square root of 3x plus 1 is equal to x plus 1. First step is to subtract 1 from both sides, leaving us the square root of 3x is equal to x. And then I'm going to square both sides, so 3x is equal to x squared. And then I'm going to move everything to one side and set it equal to 0. And now I'm going to factor out an x. So we find that the intersection points are at x is equal to 0 and x is equal to 3. And this is going to help me get a picture. And I'm just going to graph the shape that we're trying to find the area between. In order to find the y-coordinates of our intersection point, we'll just plug it into one of the functions. And since the linear function g of x is easier to use, I'll use that one. If I put 0 into g of x, I get 0, 1. So we have an intersection point here. And then if we plug 3 in, we get 4. So at 0, 1, and 3, 4 are our intersection points. And I'll draw g of x first since it's an easier function to graph. It's just a linear line. So we have a straight line. And then f of x is starts with the square root function, so we're going to have some concavity to it, and we'll draw it in there like this. So these are the two functions that we want to find the area between. And the formula for area is equal to the integral from a to b of top function minus bottom function. And that's why it was so important to draw it, so we could see which was the top function. And here we have f of x minus g of x dx. And now we can add in the numbers for this problem. In our a and b, remember, since we're using dx, we're going to use from 0 to 3 of f of x, which was our red function. I'll write it in red, which is the square root of 3x plus 1, and then minus the blue function, which is x plus 1, dx. So now that we have it set up, we need to solve the integral. And here I'm going to simplify. So I have from 0 to 3, and we have plus 1 and minus 1, so the ones are going to cancel each other out. We're left with the square root of 3x minus x dx. And now I'm going to rewrite this as two integrals because we're going to need to use the u substitution for one of them and not for the other. So I'm going to write it from 0 to 3, and I'm going to rewrite the square root of 3x as 3x all raised to the 1/2 power dx minus the integral from 0 to 3 of x dx. And now for the first part of this, I'm going to set u equal to 3x. du ends up being 3 dx. And then I have 1/3 du is equal to dx. And remember, when you switch your variable, we're going to need to change our limits of integration. So I'm going to plug the 0 into x, and u is equal to 0 still. And then when I put 3 into x, I get 9, 3 times 3. And then 3x is equal to u, 1/2. And then dx now is equal to 1/3, which I'm going to put on the outside of my integral, times du. minus the integral from 0 to 3x dx. Next step is to integrate both of them. So I have 1/3 and then we have u to the 3/2 divided by 3/2 from 9 to 0 minus x squared over 2 from 3 to 0. And then I'm going to clean up the numbers here on the left integral, or where the left integral was. So we have 1/3 divided by 3/2, which is also the same as 1/3 times 2/3. So I have 2/9 u to the 3/2 from 9 to 0 minus x squared over 2 from 3 to 0. Now I'm going to evaluate. So I have 2/9, and then we have 9 to the 3/2, which is equal to 27, minus 0 to the 3/2, which is 0, minus, we have 3 squared is 9 over 2, minus 0 squared over 2 is 0. And when we clean this up a little bit, we get 54 over 9 minus 9/2, and this gives us 3/2. And remember, we're doing area, so we're going to do units squared. And that completes this area between the curve.